Hey guys, these are your gravity notes for this unit. So this is on the universal law of gravity. This law was proposed by Isaac Newton, and it basically says that your force of gravity between any two objects is going to be inversely proportional to the square of the distance between those object centers. All right. So if you look at this diagram here, we have object 1 or M1 and we have object 2 or M2. So the green and yellow or gold or whatever color you want to call that. And then it's cut off at the bottom here, but you've got the distance between them. All right. So your formula you're going to use is your force of gravity equals G times M1 times M2 divided by your distance squared. So G is going to be a constant. I'll give that number to you on the next slide. You're going to take the masses of your two objects. It doesn't matter which object is 1 and which one's 2. And then you're going to square your distance. All right. So this is, again, that formula written how it's written on your formula sheet. And then G is always going to be 6.67 times 10 to the negative 11th newtons times meters squared per kilogram squared. So all of this is the unit for this constant. It is not a separate formula. Every semester, kids think on the formula sheet that this is its own formula, and it's not. These are units. This is the unit for this number. It is not something you're plugging other numbers into, right? It may sound dumb, but it happens every semester, right? So our example problem here is we want to determine the force of gravity between the Earth, which has a mass of 5.98 times 10 to the 24th kilograms, and a 70 kilogram physics student. If the student is standing at sea level, there's a distance of 6.38 times 10 to the 6 meters from the Earth's center. So we're going to plug all of that into our formula. And I didn't copy the formula onto this page, but you've got that 6.67 times 10 to the negative 11th, that constant for G. And then the masses, it doesn't matter which one we plug in first. So I went ahead and put the mass of Earth first, since it was written first in the question, and then times that by 70, and that's divided by our distance squared. All right, so I went ahead and just did the top row of numbers, and that equals 2.79 times 10 to the 16th, and then I squared that bottom number here and got 4.07 times 10 to the 13th, and then you'll divide that. All right, so that should give you 685.5 newtons as your answer. All right, and depending on how you round it as you went through the problem, you might get a number slightly different than that, but there is always that acceptable range of what I'll accept on a free response question. Right? When you are typing these scientific notation numbers into the calculator, my recommendation is use that E key. So like for this 6.67, I would type in 6.67, hit the second key, and then normally right above the 7, there is an two capital E's, and you would hit that and then type in negative 11. So your screen would read 6.67 E negative 11. Then hit multiply. 5.98, hit second EE, 24. That E takes care of this times 10 part. Right? Generally, there's less mistakes when students use that. When you're trying to type it in the long way, a lot of times your calculator may not do exactly what you're trying to get it to, because it's going to do order of operations and you may format something differently. So by using that shortcut, it helps your calculator do exactly what you want it to do. So my recommendation is do that. And if you're not really sure what I'm saying, just ask me in class and I can help you out with that. All right. Anyway, thanks for watching. Hope this video helps. I'll see you guys in class.